Good morning, my dear friends. Welcome to my YouTube channel. Today we are going to discuss about the two important missions of NASA, Japan. One is xrism and SLIM. So these are the two missions that are supposed to be launched on 27th August 2023. So because of some technical delay, they have been postponed. So xrism is also pronounced as XRISM and SLIM. So actually, surprisingly, these two missions are the successive missions. For example, XRISM is the fourth attempt of JAXA, Japanese Aerospace Exploration Agency, to send an X-ray telescope, X-ray observatory into the space. SLIM is the moon lander that is supposed to be soft land on the surface of moon. So, what are these two missions and the features of these two missions? Let us discuss. Number one, xrism or XRISM, X-ray imaging and spectroscopy mission led by JAXA, Japanese Aerospace Exploration Agency, in collaboration with NASA. So, and it is also have some contribution from European Space Agency, which is scheduled to be launched on an H2A rocket from Japan's Tanegashima Space Center. So, the collaborative agencies of this XRISM are JAXA, NASA, and European Space Agency, and the launching vehicle, which is supposed to carry XRISM and SLIM, is H2A rocket. Some of the things we hope to study with XRISM include the aftermath of the stellar explosions. For example, if a black hole explodes or a um, neutron star explode or any explosion, stellar explosions, are near light speed particle jets launched by supermassive black holes in the center of the galaxies. So every galaxy will be anchored by a black hole. So every major galaxy is anchored by a black hole, and the expulsion or explosion of these black holes results in the release of certain light. Or what are the aftermath events of the explosion of the black holes will be observed through the X-ray spacecraft called as XRISM. On this launch along with this launch, JAXA SLIM Smart Lander are for investigation moon designed to demonstrate accurate pinpoint lander lunar landing techniques by a small explorer. Actually, uh, Omo Tanisha and Hakuto are the two important landers that has been attempted by NASA in Japan. Okay, actually, Omotenashi is a impact probe, whereas in the case of Hakuto is the private space lander which was supposed to be land on the South Pole in 2019, but it was unsuccessful. Hakuto was unsuccessful. Omotenashi was carried through the spacecraft called as Artemis 1 project, and that one Omotenashi was impact, so it was hard landed on the surface of moon. NASA provided a laser retro reflector array for SLIM, as both agencies cooperate in the international effort to further explore the moon and ultimately human exploration of Mars. XRISM detects X-rays with energies ranging from 400 to 12,000 electronic volts. So the energy of visible light is just 2 to 3 electron volts. So this will try to identify the uh, X-rays which are highly energetic, more energetic particles it will identify. Actually, XRISM is not an first attempt for the JAXA, it is the fourth attempt, unfortunately. So, for first three attempts were unsuccessful. So, let us hope this fourth mission is, at least it can also become a successful mission. The first was in 2000, when the satellite carrying the instrument crashed shortly after liftoff. And second one, 5 years later, a calorimeter aboard the Suzaku probe became inoperable when it lost the helium that was supposed to keep the sensors at close to absolute zero. And third one, in February 2016, JAXA launched Astro H and later renamed Hitomi. Only 5 weeks later, while the instrument was still undergoing calibration and tests, a software error caused the spacecraft to spin out of control and break apart. This range will provide astrophysicists with a new information about some of the universe's hottest regions. So largest structures and objects with the strongest gravity. So The entire universe is being uh, operated by the gravity. For example, satellites, planets, stars, black holes. So, among all these things, the main centric force is nothing but the gravitational force. So, largest structures and objects with the strongest gravity. The mission has two instruments. So, it has two interesting instruments. Number one, resolve, a microcalorimeter spectrometer developed in collaboration between JAXA and NASA. When an X-ray hits resolve 6 by 6 pixel detector, its energy causes a tiny increase in temperature. So what a beautiful mechanism. When an X-ray hits the small 6 by 6 pixel detector, the temperature will slightly increase. So with identifying the increase in temperature, we can say that some of the X-rays, highly energetic X-rays might have been uh, attack to the pixels. With that, we can say that where by observing the temperatures or increasing in the temperatures, we can measure the strength of the X-rays. By measuring each individual X-ray energy, the instrument provides information about the source, such as its composition, motion, and physical state. So, by measuring each and every X-ray energy, so by measuring the temperature, we can observe. So, with the measuring the temperature, we can measure the X-rays. By measuring the X-rays, we can also detect the source. What is the composition of the black hole? What is the motion of the black hole? And what is the physical state of the source of the particular X-rays? Extend was developed by JAXA. It will give xrism one of the largest fields of view of any X-ray imaging satellite flown to date, observing an area of about 60% larger than the average apparent size of the full moon. The images it collects will complement the data collected by resolve. And JAXA will send the smart lander for investigating moon or SLIM to the moon to demonstrate accurate lunar landing techniques while also placing the X-ray imaging and spectroscopy mission in low Earth orbit on the same launch to study extreme celestial phenomena. SLIM, also known as Moon Sniper in Japanese, will take it slow to the moon. It is expected to arrive in lunar orbit 3 to 4 months after launch. So as like that of the same as like that of the Chandrayaan 3. After 2 months or so in orbit, the spacecraft will make its 20-minute descent to the surface, aiming to land within 328 feet of its intended target, as we already discussed. Pinpoint landing is going to be achieved by this SLIM. This is a key part of the mission, as accuracy of conventional landers is on the order of several kilometers. After a month or so in orbit, After a month or so in orbit, next, the spacecraft will aim to land on the slope of Shivoli crater. The relatively fresh 984 foot wide, means 300-meter impact feature within a Mare Nectaris at 13 degrees south latitude and 25 degrees east longitude on the near side of the moon. So, so in this video we discussed about the SLIM and xrism spacecrafts, which are supposed to be launched by JAXA in collaboration with NASA and some collaboration from European Space Agency. So thank you very much. We'll continue in another session.